In this video, we will derive the quadratic formula to solve quadratic equations. Let us take our general form ax square plus bx plus c equal to 0. Now, for deriving the quadratic formula, we are going to use completing the squares method for this equation. But for that, the first term has to be a perfect square. Now, so if we multiply this by one more a, you'll get an a square. And if you also multiply it by 4, which is a perfect square, so we multiply this whole equation by 4a. So 4a multiplied by ax square plus bx plus c equal to 4a multiplied by 0. Now opening the brackets, you get here 4a square x square plus 4abx plus 4ac equal to 0. Now it is not necessary to take this 4, but if we don't take a 4, here we will not get any number and the middle number is 2ab. That is why not to get a fraction we have taken a 4. Now these two terms, using these two terms we are finding the last term. So this will be written as 2ax whole square plus 2 into 2ax, and now you have to find your last term. Here we have 4abx, out of which 2 into 2ax, that is 4ax is there, so you need to multiply by a b. That means our last term is b square, and if you are adding a b square, you will also subtract a b square, and then your plus 4ac equal to 0. Now these three terms together here will be written as a plus b whole square, that is 2ax plus b the whole square, and taking these two terms on the other side at the same time, we will get plus b square minus 4ac. Now taking square root on both sides, so you get 2ax plus b equal to plus or minus root b square minus 4ac. We need to find the value of x, so let's first take the b on the other side. So here you will get 2ax equal to minus b plus or minus root b square minus 4ac. Now taking the 2a on the other side, we get x is equal to minus b plus or minus root b square minus 4ac upon 2a. So this is the root of the quadratic equation, which is given in terms of the coefficients and the constants. And there are two roots, one with plus root b square minus 4ac and the other with minus. Now let us understand how can we know the nature of roots of the given quadratic equation by just finding the value of b square minus 4ac. We'll do 3 examples for doing the same. Let's take the first one, 9x square minus 6x plus 1 equal to 0. So here a is 9, b is minus 6 and c is 1. Let us find the value of b square minus 4ac. That's going to be, b is minus 6. So minus 6 square minus 4 into a, which is 9, into c, which is 1. And that will give you 6 square, that is 36, minus 9 fours are 36, which gives you a 0. The value of b square minus 4ac is 0. Now let us see the roots. What were the roots? The roots were x equal to minus b plus or minus root b square minus 4ac upon 2a. Now this whole value we have got as 0. That means what? The root is just, this whole is going to be 0, so the root will be just minus b upon 2a, and that's going to give you a minus of minus 6 upon 2 into a, that is 9. 2 into 9. So that's going to give you 6 and 3 ones are and 3 nines are. So you will get x is equal to minus into minus plus 1 upon 3. So what you observe here, that x has only one value, that is 1 by 3, or two 1 by 3s as the values. Now let us understand this one. Here you have a2, b minus 7 and c as 3. Let's find out b square minus 4ac. So that's going to be minus 7 square minus 4 into 2 into 3. And that will give you a 7 square is 49 minus 4 to the 8 is 24. And that gives you a 5 and a 2. Right? 25. So b square minus 4ac's value is 25. Now let's find the root. So x is going to be minus b plus or minus root 25 upon 2a. Let's write the values in the next step. Minus b, that is minus and minus 7 will give you a plus 7. And one value of plus root 25, again this is a perfect square, so you will get a 5 upon 2a. A is again 2, so 2 2s are 4. One value will be with plus 5 and another value will be 7 minus 5 upon 4. So the two roots are going to be x equal to 12 upon 4, which gives you a 3. And this will give you a x equal to 2 upon 4, which gives you x equal to 1 upon 2. So here you see you got two values of x and both of them are rational numbers. Now let's see the next one. a2, b minus 4 and c6. So here b square minus 4ac gives you a minus 4 square minus 4 into 2 into 3. That gives you 4 4s are 16 and minus 4 2s are 8, 8 3s are 24, and you get a minus 8. So b square minus 4ac here is minus 8. So our roots are going to be minus b plus or minus root of minus 8 upon 2a. Now just observe this. Root of minus 8. Now such numbers, root minus 8, do not exist in the real number system. And that is why this equation does not have a real root. And because of what it does not have a real root? Because of the value of b square minus 4ac. It is negative. That means that when the value of b square minus 4ac is less than 0, there is no real root. Okay, this is one condition. Same way, when the value of b square minus 4ac is equal to 0, then there are two identical roots, same roots. In both the cases, you will have 1 upon 3, 1 upon 3. Whether you take as plus value or minus value, both cases 1 upon 3. So, when your value of b square minus 4ac is equal to 0, you have two identical roots. And the middle example you observe, here your value of b square minus 4ac was greater than 0. So, b square minus 4ac, when its value is greater than 0, you have two distinct roots. And in that case also, if b square minus 4ac is a perfect square, then the roots will be rational. and if it is a not a perfect square, then its roots will be real. So the value of b square minus 4ac determines how or what kind of roots you will get, and that is why b square minus 4ac is called the discriminant, as it discriminates between the roots. Thank you.